In this video, we're going to review the trig ratios, sine, cosine, and tangent ratios for right angled triangles. And we're going to relate the position of a point on the unit circle to the value of trig ratios measured in radians. So let's just remind ourselves of the trig ratios. You can see I've got my right angled triangle here and my sides are labelled opposite, adjacent and hypotenuse. So we go back through our Year 9 maths, we know that the sine of the angle is the opposite over the hypotenuse. We know that cos of the angle is adjacent over hypotenuse, and that tan of the angle is opposite over adjacent. So let's look at the trig ratios specifically with this particular angle that I've got here in the unit circle. So you can see that the circle has a radius of 1, so it's a unit circle. And I'm going to create a right angled triangle for this point on the unit circle, and because it's a unit circle, it's sitting on the Cartesian plane, so it has coordinates. And the coordinates I've got here for my point P are A is the x coordinate and B is the y coordinate. So I'm going to take this right angled triangle here and I'm going to put it over here to the side. So let me just show you what I've got. I'm going to take this right angled triangle that's sitting here and move it over here. Now you'll notice that I have labelled this side length as A, because this A value here, say if that A was 0.5, then that length there is 0.5. And if this B value up here was 0.8, then this length here would be 0.8. And that's why I've labelled A and B here. So let's go through, and for this triangle here, let's find sine, cos and tan. So our hypotenuse is 1, so for both sine and cos, they're both out of 1. So sine is opposite, which is B, divided by hypotenuse, which is 1. So you have sine of theta is equal to B. So the coordinates for our point here, that B, is in fact sine of theta. And this value here is in fact sine of theta, which is that length there. For cos, over here in this triangle again, for cos it's adjacent over hypotenuse, so it's A over 1. So you end up with cos of theta is equal to A. So that means that the y coordinate of our point is in fact cos of theta. And this value here is cos theta. That distance there is cos theta. And tan is opposite over adjacent. So our opposite is B, our adjacent is A. So we actually just found out that B was equal to sine theta and A was equal to cos theta. And so what we have here is a relationship between tan theta and sine theta and cos theta. So tan of theta is sine theta divided by cos theta. So what we've got here is that our cos theta values we're going to read off our x-axis, and our sine theta values we're going to read off our y-axis. And that the position of this point here, P, is at the coordinates cos theta, comma, sine theta. Let me just write that. So P, our position, our point's position, which is relative to the angle here. So I can pick up this point and move it around and it will change this angle here. So that means that the point is going to change its cos value and sine value based on the angle that's in here. So the coordinates of the point are in fact functions of theta, which is why we've got this point thing written as a function of theta. So we can see that we have sine theta values and cos theta values on the unit circle, and I'm just writing them up here. So let's find a way of actually visualizing where tan of theta is. So here's a different view of tan. So here is our point again, and the coordinates of the point are cos theta, sine theta. And I've still got theta as my angle. And I'm going to take this right angle triangle here. I'm going to concentrate on that. I know I've got the coordinates here already, but I want to show you how this actually works. I'm going to take this triangle here and pull it over here, so that the horizontal line here is a distance of 1, a length of 1, because it's a unit circle and it comes out to 1 here. And then this is your green line height that I've got here, this tangent line here. So this is a tangent at x is equal to 1. So if I go through and I use my tan theta is equal to opposite, which is d, over adjacent, which is 1, you can see that tan theta is equal to that distance here. Tan theta is d, which is that length there. And so tan theta is that length there. And as we found out before, if I look at that length there and I look across and I read it off the y-axis, that whatever the value there is on the y-axis, so this goes across here, this value there, that number, is tan theta. So you can read tangent values for angles from this tangent line. Read your tan values from the tangent line.